We are now, we're going to just look at this graphing linear and exponential equations practice, okay? So we got both the linear, we've also called that the arithmetic, right? Linear, special type of arithmetic pattern. Exponential, that's our geometric. So we're just going to do a bunch of graphing, okay? So for the linear, these first ones, we should be able to recognize that they are linear because their variable is not an exponent, okay? And remember, the slope-intercept form, y equals mx plus b, which is kind of how this is modeled. Generally, that's a graphing format. So where our m is going to be our slope, okay? Our b is our y-intercept. So we see the y-intercept on the y-axis, and the slope we see as the rise over run, the change in y over the change in x, okay, the delta y over delta x, which means change. So let's jump right into it. So we start at -3, so there's our -3. Then our slope is -7 over 3. Now that negative can go either with the 7 or with the 3, doesn't matter, okay, should probably put it with the 3 though. Negative on top means we go down. Positive on the bottom means we go to the right. So I would go down 7, kind of off my graph, right? And to the right 3, about right there. If I thought of it as the other way, we'd go up and to the left. So I'd go up 7, to the left 3, okay? Which would kind of be a better idea to look at. And then I draw my graph, and that's all we got to do, okay? Because we've got the y and the x, because it's that slope-intercept form, pretty much all of these are going to be continuous, okay? So yeah, I think that works. So if you have this, you should probably try to do it at home on your own first, and kind of watch some problems if you need some help, that kind of stuff, okay? So let's take a look at the next one. Now we've just got y equals 2x. If I were to add that y-intercept, it would just be a plus 0. So my y-intercept is actually the 0, the origin. And then my slope is 2. To make it a fraction, I just put a 1 under it. Anytime we have not a fraction up at the top, we can make it by putting a 1. So I'm going up 2 because it's positive to the right 1. So I go up 2 to the right 1. Then from that point, up 2 to the right 1. Up 2 to the right 1. And generally, I only need about 3 points. I could do the opposite and go down 2 into the left 1 if I really wanted to get a bunch of points. But we just draw our line, and we're good to go. All right, so that's all we got going on here. Just a bunch of graphing. So plus 3, that's my y-intercept. Slope of 4 over 5. They're both positive, so that's up and to the right or down and to the left. Because I could think of it as -4 over -5. That's the same thing as 4 over 5. So I go up 4, to the right 5. Or, like I said, we can go down 4, to the left 5. Because if we started right here, we would go up 4, to the right 5, okay? That's why we can go either direction, okay? It really doesn't matter. All right, positive 3 again for my y-intercept, slope of 5 over 3. So I'd go up and to the right, but I'm probably going to run out of space, aren't I? Now, I could go to the right 3 first and then up 5, right about there, okay? Or again, I can think of that same pattern, and I can apply it else the other way, right? Because that slope is just simply taking us vertically and horizontally to get to the next point for our diagonal line. But it's actually not part of our equation, so we really shouldn't leave, if we were to draw that, we really shouldn't leave it in there, okay? All right, 5 and 6. Positive 1 for my y-intercept. Slope of -1 over 2 or 1 over -2, same thing. So down and to the right or up and to the left, which is the same process. So if I went down 1 to the right 2, we'd look like this. If I went up 1 and to the left 2, it would look like this. Oops. Either way, it's the same pattern. Because it's continuous, we keep going in either direction. That's why we should put arrows at the end of our stuff. Okay, positive 2, so up 2. Slope of negative 2 over 3, so down and to the right. I could think of it just that way. 1, 2, 1, 2, 3, down to and to the right. And 3 is enough to draw my line, so I can just draw my line. And we could notice that if it was 2 over negative 3, we'd go to the left 3 and up 2, which is basically where we drew our line, okay? That's all there is to it on this stuff, okay? So we've just got some more practice problems, so try these on your own first. But we're just going to kind of jump right through it. Now, if there's no number in front, think of it as like a 1x because of that multiplicative identity property of 1. It says we can put a 1 there. So for a slope, it'd be like 1 over 1. So up 1 to the right 1. Starting at 4, I go up 1 to the right 1, up 1 to the right 1. It's enough, and I can draw my line. Okay, number 8, I've got a 2, so make that a 2 over 1 for our slope. We start at 3. We go up 2 to the right 1, up 2 to the right 1, or down 2 to the left 1. That same pattern, right? That was a horrible drawn line, but it works. Okay. Now, number 9, this one's an interesting situation. Notice we have no y value. We just have an x value. So if I just go with my x value at negative 5 on the x-axis, I would draw just a dot right there. However, if my y value were negative 1, my x value would still be negative 5. If it were negative 2, it would still be negative 5. If it were positive 1, it'd be negative 5. 2, negative 5. Do you see what we're doing here? Basically, we're just drawing a vertical line here because at all these places where x equals negative 5, y could be anything, but x is definitely going to be a negative 5. So when we see just an x with no y, then it's a vertical line. Okay? So you want to pay attention to that. Number 10, start at 5, slope of negative 7 over 3. So I could make it again 7 over negative 3, but up 7 wouldn't really help me out too much, would it? So instead, we probably just want to go down 7 to the right 3. Now, because our linear equations are just straight lines, really I only need 2 points, and that's enough to graph it. So I could just use those to graph my line and call it good. Number 11, positive 1 to start us off, negative 3, so that's like negative 3 over 1, down 3 to the right 1. Make sure that this slope is starting from your y-intercept, not from the origin. I see that mistake quite a bit. Okay, so you've got to make sure you're giving it the right starting point, which would be that y-intercept. And then we just keep that same pattern, down 3 to the right 1. And there is my graph. We sketch it out. We call it good. Okay, number 12, negative 4. That's like negative 4 over 1, starting at negative 5. So negative 4 over 1 would take me down and to the right. Well, down 4, I'm going to run out of space. So maybe I could bump that down and be positive 4 over negative 1. So I'd go up and to the left instead, which is the same situation. Okay. Same pattern. Ooh, that was a horribly drawn line. Let's try that again. Not much better, but that'll work better. Okay, so you got to pay attention to that because that does make a difference. Okay, all done with this page. Okay, now we should notice something different here. Okay, now we are no longer with our linear. Now we're dealing with some exponential. The reason I know it's exponential because I see multiply and I see the exponent. Okay, and it's kind of slope-intercept, not really slope, but its form, right, is y equals a times b to the x, where b is our growth, okay, our factor, what we're multiplying by, and a is our y-intercept. Okay, so my y-intercept at 3, I start at 3. Now, like I said, it's not slope, so this timesing by 2 doesn't mean I times this way by 2 and then this way by 2. It's not like the slope, okay? What it means is every time we move to the right one, we're going to times by 2. So I take my y value, 3, times it by 2. I go to the right one, times it by 2, takes me up to 6. Notice this is 0.5, not 1. I take 6, times it by 2, move to the right one. 6 times 2 is 12. Take 12, times it by 2, move it to the right one, and we get 24. Okay? Now, that gives me half of my equation, so I want to go backwards. And if I go backwards, I do the opposite. I divide by 2. Okay, so 3 divided by 2 would be about 1.5. 1.5, about 0.75. And then it just keeps getting closer and closer to that y or x-axis. Now, we've got to remember one other thing with this, right? When we're graphing with an exponential, basically that first step really should have been to recognize where our asymptote is. Okay? Remember, that's the invisible line that my line is never going to cross. Okay? So I really should have thought of that first. Then we can get the y-intercept, the start. Then we can use the growth to do, left side and right side. And then we can draw the line. Okay? So I would start down here by my asymptote, and I just kind of curl it up and keep it going. So it's never going to cross that asymptote. You got to remember that. And generally speaking, our asymptote is going to be that x-axis. The only time that changes is if we're going to shift it up or down, which is like putting a number plus or minus up here, okay? That's generally the only time that that's going to happen, okay? All right. So we figure out where our asymptote is, and if you want to, draw the dotted line. If not, just imagine it being there. Then find our start, which was 1. Then my growth, times them by 5, so I move to the right one. 1 times 5 is 5. Oops, wrong place right there. Move to the right one. 5 times 5 is 25. So 5 times 25 would be 125, way off my graph up there. And I also kind of know as we get smaller as I move to the left, so I would divide by 5 here instead of times by 5. 1 divided by 5 is 1/5, so it's really close. So I know that I'm basically going to just skirt right here, and then we'll shoot up really quick like that. Okay? And these, by the way, because as we look left to right, they're going up, right? We follow this up. These are what we call growth, right? Exponential growth functions. Whereas when we look at the next ones, now we're timesing by a fraction. Timesing by the fraction, timesing by 1/2 is the same as dividing by its reciprocal of 2/1, or just 2. So when I think of this as I move to the right, now instead of timesing by 2, I'm dividing by 2, which is the same as timesing by 1/2, gives you the same result. Okay? So if I'm going left, we do the opposite. We would times by 2, or divide by 1/2, which would be timesing by 2. Okay, so again, first let's think we're not adding or subtracting anything up here. So I can draw that asymptote for both of them, really. Okay, and then I think, okay, starting at 1, timesing by 1/2, dividing by 2. 1 divided by 2 is 1/2. Divided by 2, 1/4, 1/8. So, oh, I made a mistake there, didn't I? That should have been 1/2. Then that, then that. So as I go to the right, we're going to be curving down, aren't we? So going to the left is what I need to do to kind of get a good idea of what this is going to look like. So if I times 1 by 2, we'd get up to 2. 2 times 2, 4. 4 times 2, 8. And so I can see that it's kind of curving down like this, and I'm going to get really close to that asymptote. Okay. Now, number 16, very similar. We start at 4, because we already have our asymptote. We're timesing by a fourth, so that's like I'm dividing by 4 as I go to the right. So 4 divided by 4 is 1, then 1/4, and smaller and smaller. But I move to the left, we're timesing by 4. 4 times 4 is 16. 16 times 4 is 64? I believe so. So clear up there. So we're going to start clear up here and shoot down, get really close to that asymptote, and then kind of just level it out as best we can. And these ones, notice that these ones now, as we go left to right, are going down. These are what we call exponential decay relationships, okay, because they're getting smaller. All right? All right, so we've got... Oh, what is wrong here? Should be able to move that around. Oh, there we go. That was weird. So we got 2 more problems right here, or 4 more, I guess. And yes, that was a bell, so I paused during it. I won't be editing that out because my editor's been messing with things, so we'll just have to live with that beep. So, our asymptote, there's no plus or minus here, so it's going to ride along here. Okay, and in fact, let's do them a different color. Let's kind of look at them all. 18, same idea. Okay, 19 and 20, same idea. So we've got the asymptote on that x-axis. Okay. Now, if we look at number 23 and 24, these ones are actually going to be different. Okay. So we won't look at those ones yet. Okay, so 19, we've got back up to green. So start number of 5, go to my y-axis, have 5, times in by 2. So as I go to the right one, times by 2. To the right one, times by 2. To the right one, times by 2. As I go to the left, I think in terms of dividing. 5 divided by 2 is 2.5. Divided by 2 is like 1.2125. Okay, we can see it's just starting down here low, and it's going to shoot up here pretty quick. Okay, number 20, starting at 2 and timesing by 2. So going to the left would be dividing by 2, so drop down to 1, 1/2, 1/4. Going to the right, it would be 4, then 8, then 16. And we would just start down low and just shoot up there. So it's not shooting up quite as quick, but you know, starting at 5, starting at 2 affects that. All right, going back up to these 2 because we skipped them. Same idea. Start at 1, times by 5 every time I go to the right. So we'd have 5, then we'd have 25, then 125. Going left, go down to 1/5, so I know I'm starting here low. And just graphing it up high. So once you got the basic idea of what it's going to look like, it's pretty easy to just have a few points and get an idea of how it's going. For number 9, we're timesing by 1/3, which is the same as dividing by 3. But I start at 9. So I move to the right, that would knock us down to 3, then to 1, then to 1/3. Going to the left, I would times by 3. So 9 times 3 would be 27, which gives me a pretty good idea that we're starting up really high. And we're curving down pretty quickly, and I'm going to run with that. Okay? So, yeah, looking pretty good, right, guys? Okay, 21 and 22, same concept. So starting at 8, timesing by 1/2, which is the same as dividing by 2. So as I go to the right, each time I go 1 to the right, we divide by 2. And we just start going down. As I go to the left, I times by 2. It looks something like that. (22), start at 4. Timesing by 3. 4 times 3 is 12. 12 times 3 is 36, somewhere up there. Going backwards, 4 divided by 3 would be like 1 1/3. And dividing by 3 would be somewhere down here, so we're definitely starting down low and then climbing up pretty high. All right? Okay. Now let's talk about 23 and 24. Because now we've got a different situation where that +2 or -2 is being added. And it might be useful to take a look at Desmos, okay, to help us with this. So let's look, and we've got 2 times 3 to the x plus 2. So y equals 2 times 3 to the x. Okay, we'll start with that base. And we'll go y equals 2 times 3 to the x. And I believe it was plus 2. And down here, let's do this. Y equals 2 times 3 to the x. And this time we're going to go plus c. Or actually k is what we really should say. So let's add that slider k. And I'm also going to go like this. Y equals k. And we're going to make that into a dashed line. Maybe. There we go. Okay. So let's move that down to 0. Actually, let's adjust that. Let's go -5 to 5. It's going by ones. That'll make it easier for us. Okay. So the idea here now is that this red line, okay, represents 2 times 3 to the x. The blue line, 2 times 3, make that a little easier to see, 2 times 3 to the x plus 2. Okay. Now this third one we can manipulate, and that's our asymptote. Okay. So as we move that k up or down, that's going to change our asymptote. So starting here at 0, we can change that asymptote by moving it up. Okay, notice it now, the blue line, that's where its asymptote is. Okay, remembering that that shifted up 2 because of that 2 right there. Okay, now if we show this green one, it's going to be in place of where the blue one is. Okay, so what we notice here now is that, or what we should notice, and it's kind of hard to necessarily see right here without being able to write on it, and maybe I can hurry and take a screenshot of this to demonstrate what we're talking about. Okay, doing all sorts of cool things. All right, here we go. So our original one, okay, had an asymptote right here, didn't it? Okay, so our starting point was here at 2, which we saw right here. We also see that on the blue, but if we look at our blue starting point, our blue y-intercept, it's actually 4. Okay, but notice that it's 2 away from its asymptote. Okay, so this plus 2, it's basically taking everything and just shifting everything up by 2. Okay, that's really all that is happening here, is we're shifting things up by 2. So to graph it, the easiest way to do that is to take the original, kind of plot it, and then move everything up. So we don't need that anymore. Okay, so here's what I would, there's 2 ways to do it. I'll show you both ways. Okay, the first way I would do it is I would recognize, okay, this is where my original one would be, right? It's asymptote right here. Then it would start at 2, and we'd times by 3 going up to the right. going to the left, we divide by 3, and so, you know, it would look something like that. So my graph would look something like this if I were to graph it, okay? However, I wouldn't graph it, so let me back up. I would just kind of leave it like this, okay? So then what I would do is I would say, okay, now let's apply this plus 2. So plus 2 is changing everything up by 2. So my new asymptote is right here. My new point right there is right there. This one right here. This one right here. This one right here. And so there's my new line. Well, there's my actual line, right? And that would be that whole thing. So it's kind of like you get rid of this plus 2, and then you plot that, then you just add in the plus 2 to it. Okay, that's one way to attack it. The other way would be to go like this. Let's say, okay, now we're subtracting 2. So I'm going to take my asymptote, which normally would be here on the x-axis, and it's actually going to be here at -2. Okay, now this one actually has a negative out front, so it's going to be a little different. Okay, but normally I would have started at -2. Maybe let's go back here. Okay, so now we're going to be minusing 2. It's actually got a negative out front too, which is going to change how everything looks, isn't it? Okay, so by shifting it down, okay, the other idea here is that when we see from the asymptote to its start, that was -2. So from my asymptote down to my start, it's -2. So it's like I make this the new x-axis. That's kind of like the concept there. That the second concept that we could do here. Okay. So what I would then do, so I'd be going down 2 from my asymptote. So I'd actually have my start at -4. Now we're timesing by 1/2, so that's dividing by 2. So if I kind of make a table here and say, okay, I was at -2, dividing by 2 would be -1, -1/2. Okay, as I'm going to the right. If I were going left, it'd be -4, -8. But I'm going to subtract 2 from everything. So instead of -8, that would be -10. Instead of -4, that'd be -6. Instead of -2, that would be -4. Instead of -1, -3. Instead of -1/2, -3.5. Right? No, -2.5. So, a 0, I start at -4. As I go to the right, we'd be at -3, and then -2.5. And so we can see I'm kind of getting closer this way, because it's kind of flipped everything, that negative up there. Okay, as I go to the left, it would be at -6, then -10. And if we kept going, this would be -16, so -18. So then my graph is kind of completely flipped around, but we can kind of still see that same shape. Okay, so 24 definitely is a super, super difficult one. But there's kind of how we can deal with those pluses and those minuses out there, okay? I probably think this way is an easier way to do it. But it's kind of up to you which way you want to do it. All right. Now, these last ones were just kind of some different ways to graph that we haven't really talked about. So I'll just talk about them briefly. Okay, we already know what a y-intercept is, right? So we can easily graph that at 5 and at -4. The x-intercept is the same concept, just on the x-axis. So that'd be 1, that'd be -2. I've got 2 points. I can draw my line. Okay, not too bad, right? Now, using that concept, I could actually graph with 27, 28, 29, and 30. Okay? Or I could try to put it into slope-intercept form. So I'll do 27 like y-intercept. 28 will turn into slope-intercept form. So to do that, we basically have to get y by itself. So I'd subtract 2x from both sides. Get negative 5y equals negative 10 minus 2x. Divide by negative 5. That would be 1. I get y equals positive 2 minus, or actually plus, because negative over negative is positive, 2/5 x. So I know I start at 2. I know that I'm going up 2 to the right 5, or down 2 to the left 5. And then I can draw my graph like that. Okay? And I can work on one like number 29 as well, where I'd subtract 6x and 2. So I'd get y equals negative 6x minus 2. Start at negative 2. That's like negative 6 over 1, so down 6 to the right 1, or up 6 to the left 1. And we get that one. Okay? That's if you want to change it to the slope-intercept form. The other way to do it is to recognize there's a concept going on here. For the x-intercept, that point would be negative 2, 0, or 1, 0. Basically, the y value is always 0. Same with the y-intercept. That would be 0, 5, or 0, negative 4. In that case, for the y-intercept, the x is always 0. So I use that concept. So if I want to know what the x-intercept is, I make the y equal to 0. So that y becomes 0, then I solve for x. 5 times 0 is 0. 2x minus 0 is 2x. 2x equals negative 15. Divide by 2, and x equals negative 7.5. So on my x-axis at about negative 7.5, I draw my point. Then to find the y-axis, or the y-intercept, I make x 0. So it'd be like 2 times 0 equals 5, not equals, minus 5y equals negative 15. That becomes 0. Negative 5y equals negative 15. Divide by negative 5. We get y equals positive 3. So positive 3 for y right there. And there's my graph. Okay. Again, number 30, we can take a look at that same concept. Okay, so to find my x, I make the y equal to 0. To find my y, I make the x equal to 0. And then I just solve. That becomes 0. 20 equals negative 5y. Divide by negative 5. And we get a negative 4 equals y, my y-intercept. That becomes 0. So 20 equals negative 6x. Divide by negative 6. And 20 divided by negative 6 is negative 3 and 1/3. Right? Because it would be 6 times 3 would be 18, 2 left over, 2 over 6 would be 1/3. So negative 3 1/3 would be about right there. And we'd get our line. Okay, I could still change that to slope-intercept form by adding 6x. Getting 6x plus 20 equals negative 5y. Divide by negative 5. And I would get negative 6/5 x minus 4 equals y, or y equals that. Y-intercept of 4. Boom. We're going down 6 to the right 5, or up 6 to the left 5, which basically you can kind of see that same pattern. All right, so there's a bunch of different ways of graphing. And yeah, there we go, guys.